Okay, this is for the final mechanics. We have 1, 2, 3, 4, 5 past papers. In total, we have 2, 3, 6, with 9 questions. Very easy. I guess we'll start. I'm starting with, I think it's written down here. Um, paper 4, October, November 2020. شو هذه؟ 2020 شو? 2022. Is this 2022? Yes, October, November 2022. Paper 4-2. We have questions 2 and 3 included. Okay, a particle P of mass 0.4 kg is in limiting equilibrium on a plane inclined at 30 degrees to the horizontal. Show that the coefficient of friction between the particle and the plane is 1/3. Okay, so to make our life easier, we're going to draw the plane over here. Okay, we're going to just draw it like this. Okay, 30 degrees, and we're going to say this is P over here, right? Okay, so we can understand what's going on. It's in limiting equilibrium on a plane. Limiting equilibrium means that uh it's not moving, it's rest. And limiting equilibrium basically means it's about to start moving, but the friction is pulling it back, but it's at rest, okay? So it's reaching the maximum friction. Other things show that the coefficient of friction between the particle and the plane is 1/3. We're gonna start always by drawing our FBD, okay? And we're gonna draw the FBD the proper way now, because if you guys remember, I told you that I used to draw the FBDs for inclined planes like this, and this is the way. This is actually wrong. It was rejected by the regional. So even though it's correct for some teachers, to be safe, we're gonna draw it the proper way, which I'll show you now. And I have a video on my channel that talks about how to draw it. Anyway, it's on an inclined plane. But we're gonna incline the y-axis like this and the x-axis like this, right? So we're gonna draw. This is the y-axis, and this is the x-axis. Okay. طيب, what forces do we have? Okay, we always have our weight acting vertically downwards. And what's the angle between the weight and the vertical? 30 degrees, right? Okay, what else do we have? We have what's stopping it from moving down? Always we have friction, right? Vector symbol. Okay, and we always have the normal push because it's on a surface, right? So N with vector symbol. Always remember, since we have an angled force, we have to resolve it into components. Cambridge marking scheme doesn't say you have to do this, by the way, but Sabbath's marking scheme does. Okay, so we have to resolve it into components. We're going to make it here Wx and here Wy. Okay, I'm going to redraw this properly because it's very small and I don't want to have it cramped. Okay, I'll cut to when I draw it. 1 second. Okay, so it's going to look like this. And since we know it's limiting equilibrium, we can now resolve our sigma fx and sigma fy. Let's start with sigma fx. It's going to be equal to 0 because we're at rest, right? Okay, always put your arrows over sigma. Okay, let's see. What are my x component forces? I have F and Wx, okay? So we can say F is equal to Wx. And you can't keep it like this. We're going to simplify this. What's F? We know F is mu times N. صح? Wx is equal to mg sine theta. In this case, why sine? Because the angle we have is with the vertical. Okay, so let's simplify this more. Mu times n is equal to mg. The mass is 0.4. G is 10. If not given, use 10. Huh? And then sine 30. So you're going to get mu times n. If you do this on a calculator, you get 2. Okay, this is for sigma fx. How about sigma fy equal to 0? Sigma fy equal to 0. What are my vertical forces? N and wy, right? So N is equal to wy. So N is equal to mg's cosine theta. So 0.4 times 10, because mg, let me write mg cosine theta. Mg cosine theta. So N is going to be equal to the mass 0.4 times g times cosine 30. Okay, so you're going to get N is equal to 2 radical 3. Okay, if you do this on a calculator. So, now what we're trying to find? We're trying to find the coefficient of friction. We're trying to find mu. We know that mu times N is equal to 2. And we know that N is 2 radical 3. So you can just substitute. So we're going to say mu times 2 radical 3 is equal to 2. Then divide by 2 radical 3 on both sides, you're going to get mu is equal to 2 over 2 radical 3, which is 1 over radical 3. And you can't keep it, if you put this on a calculator, by the way, it's going to give you a radical 3 over 3. Okay? You can't multiply, you can't have, and they're saying show that it's equal to this. People are going to be like, yo, wait, I got this. I definitely got the wrong answer. No, you didn't. Don't panic. You have a radical in the denominator. Remember, in math, we're not allowed to do that. What we do is multiply by radical 3 up and down. So you're going to get radical 3 over 3, which is the same as just separate it. It's the same as saying 1 over 3 radical 3, right? Just move the radical 3 to the side. It's going to be 1 over 3 radical 3. Okay? Also, if you do it on a calculator, if you put 1 over radical 3 on a calculator, or حتى 2 over 2 radical 3, you get radical 3 over 3. You get this. Okay? You get this directly. Okay? But if you want to do this, show it, I don't know. Okay? These are the steps. So you get 1 mark for this. All of this. You get 1 mark for all of this. And then you get a 3rd mark for the answer. Okay? 3 marks. That's how it works. A force of magnitude 7.2 newtons is now applied to P directly up the plane. The greatest slope of the plane means it's just pulling it up. Given that P starts from rest, find the time it takes for P to move up the plane. This one's a bit tricky, but again, bear with me. Again, we're going to draw the inclined plane just so you guys can understand. It's the same inclined plane of 30 degrees from part A. Okay? And we have the particle P. Same thing. Now it's being pulled up with a force. Oh, that's bad. It's pulled up with a force of 7.2 Newton. Okay, so it's being pulled up like this, 7.2 Newton, صح? Okay, now we're going to draw the FBD. It's the same FBD we used, but there's some differences, okay? Same FBD we draw, it's going to be slanted, right? Why is it slanted? Because we're working with an inclined plane, okay? طيب. We have our weight going downwards. Over here. Okay, what do we have? We have our normal, let me change back to red. We have our normal push, obviously, right? And we have now a force pulling it up, right? We're going to call it F, okay? I'll put in brackets 7.2 Newton, okay? Now, some people make the mistake and put friction going up because it's the same as the first one. No, Habibi, if you're pushing the box to the right, then where's the friction going to be? It's always opposing the direction of your force. So F, okay? Put the vector symbol just to be safe. Okay, now we know we have our FBD. We don't have it. Wait. I have to resolve. Remember, any angled force, you need to make it into WY and WX. Okay, what do we know? Let's start with sigma Fx. We're moving it up. We're applying a force. Anytime you apply a constant force onto a box, that means it's accelerating. So sigma Fx is going to be equal to ma. Okay, vector symbol, vector symbol. Only put the vector symbol above the a. Now don't put it above m and a. And these are the things, these small things could lose you a quarter of a mark, okay? Because mass isn't a vector. Anyway, sigma Fx is equals to ma. It's obviously accelerating in the direction of f. What are my horizontal x forces? It's accelerating direction of f, so I'm going to write f first, right? What are my on the other side? What do I have? F and wx. So minus f minus wx is equal to the mass. Remember we said it's 0.4 kg times a. صح? Okay. I'm going to move this a bit to the left because I want some space on the right. Okay, so f minus wx is equal to 0.4 a. What is f? 7.2. What's the friction? The friction is equal to mu n, right? We're going to substitute it with mu times n, right? Minus wx. What's wx? It's mg sine, let's say theta, right? Because it's the x component and our angles with the vertical, it's always sine for x, right? Let's substitute more. We're going to get 7.2 minus mu. What did we say? Why do we have to find mu here? Because we need it for the part B. 1 over 3 root 3 times n, right? Okay. Let me remove the brackets. I'll put the bracket here. Minus mg sine theta. M is 0.4, G is 10, theta is 30, so sine 30. So you're going to get 7.2 minus root 3 over 3n minus 0.4 times 10 times sine 30 is 2. Okay? Is equal to, I should have put equal to 0.48. Okay. So let's continue to simplify a bit. You're going to get, because I need a lot of space for this, man. I'm going to split this like this. Okay, I got this, right? Let me simplify this and do 7.2 minus 2, which is 5.2. Or, I'll keep it like this, okay? I need to substitute n, right? I need to substitute n. So what do I do? Now, sigma fy is equal to 0, okay? What does this mean? I'm going to continue on the right, okay? Sigma fy is equal to 0. Don't forget this vector symbols. Why fy equals 0? Because my block, is it jumping up and down? No, right? Always do sigma fx, sigma fy. It's not jumping up and down, so it's going to be equal to 0. It's not moving vertically. Type, what are my vertical forces? N and wy. Okay, so that means N is equal to wy. What does this mean? N is equal to mg cosine 30, right? Because theta is 30 and it's going to be cosine because it's wy. Okay, so you're going to get N is equal to 0.4 times 10 times cosine 30. So N is equal to 2 root 3. So I can go back over here. I'm going to substitute n with 2 root 3. I'm going to do 7.2 minus 2 root 3 times root 3 over 3 minus 2 equals 0.4a. And I'm going to get, if you put this on a calculator, 7.2 minus 2 root 3 into root 3 over 3. No. Root 3 and over 3. Root 3 cancels. 3. Whatever, I'm just going to put it in a calculator. I'm going to get 3.2. So I'm going to get that 3.2 is equal to 0.4a. If you divide by 0.4, you're going to get 3.2 is equal to 0.4, which is equal to 8 meter per second squared. So we found a, okay? We want to find the time to move 1 meter. You obviously need acceleration because you're moving, okay? That's why we found here, okay? Over here, now how do I find time? I have what starts from rest. So I have u is equal to 0. I have the distance, x is equal to 1 meter. I have a is equal to 8. I need time. Which one has x, a, t, and u? Obviously, we're going to use x is equal to half at squared plus ut plus x naught. We're going to use this formula, right? X is 1. Half times acceleration, which is 8, times t squared, plus u is 0, so this cancels, plus this cancels also. So 0. So you're going to get 4t squared is equal to 1. So you're going to get t squared is equal to 1 over 4. So you're going to get t is equal to root 1 over 4, which is equal to 0.5 seconds. Okay? Question 2 is done. Halla, question 3. Okay? Question 3. Oh my god, I hate this question so much. Wallah. Turn off my phone, it keeps just more. Hello. Okay. A particle of mass 0.3 kilograms is held at rest by 2 light inextensible strings. One string is attached at an angle of 60, and the other string is attached at an angle alpha. The tension in the string attached to the ceiling is 4, so this one is 4 newtons. Find the tension in this string and find alpha. Guys, very easy. I'm going to zoom out a bit. We have some working space now. I solved this for the periodic. We'll solve it now again. I'm going to start with the FBD. It's not angled on any inclined plane, but we're going to start with a perfectly straight y and x. Obviously, it's not perfectly straight in my drawing, but you get the gist. Okay. We're going to start with the weight of the particle. Right? And then we have to the left, we have our what? We're going to call this over here T1, and we're going to put in brackets, it's 4 newtons. Okay? Let's see. The angle here is 60. I'm going to use the angle with the horizontal. I'm going to use this one. If this one is 60, this one will also be 60. Okay. People will prefer to use 30 in this angle over here, but I prefer to use this 60 over here because they're alternate interior angles. This one's parallel to this one, but if this is 60, this is 60. Okay. Always. If the top one is 60, then the one with the horizontal is also 60. Okay. You know what? I'm just gonna use this 30 because you guys, I feel like you're gonna get confused. Okay. If this is 60 degrees, then this one's obviously 30 because they have to add up to 90 because this is 90 over here. So 90 plus 60, 150. Which one? You need to add 30 to make it 180. So we're gonna use this as 30 degrees. Okay. Type. We have Tx. And we have Ty. I'm gonna call it T1y and T1x. Okay, hello, we have our second tension, right? We're gonna call it T2. Okay, T2. Right? T2 also has its x component, T2x, and its y component, T2y. Okay. What's the angle now? This one is alpha, so this one over here will also be alpha. Okay, so I'm going to use this angle over here as alpha. Okay. I know I kind of have, that's a lot going on right now, but let me put vector symbols. Kind of try and understand it. We have T1, having T1x and T1y, angle 30 degrees with the vertical. And then T2, we have the angle also with the vertical alpha, because the angle here is alpha. So over here, it's also going to be alpha. Okay. I'm not going to use this angle and do 90 minus alpha because I feel like that would be too much work. I don't want to have, I just want it to be one letter. Okay. So we know that it's at equilibrium, it's held at rest. So we're going to start by saying sigma. That's not a sigma symbol. Sigma fx is equal to 0 with our vector symbols. What are my horizontal forces? My horizontal forces are T2x and T1x. So T2x is equal to T1x. T2x is equal to T2, the angles with the vertical, right? So it's going to be T2 sine alpha, صح, is equal to T1x. T1x is equal to T1 also sine the angle 30. Why sine? It's an x component because the angle is with the vertical, okay? We know that T1 is equal to 4 newtons. So T2 sine alpha is equal to 4 sine 30. And so T2 is going to be equal, T2 sine alpha, sorry, is going to be equal to 2. Okay? Sigma Fy is equal to 0. Vector symbols. Sigma Fy equal to 0. What are my vertical forces? T1y. Remember, if it equals 0, that means what's up is equal to what's down. So T1y is equal to T2y plus W. T1y is equal to T2y plus W. Okay, let's see. T1y, what's it equal to? It's equal to T1 cosine the angle 30. Why cosine? Because it's y component when the angle is with the vertical. So you're going to use cosine. T2y, again, is going to be T2 cosine alpha. Why is it going to be cosine? Again, same reason. We want the y component and the angles with the vertical, so you're going to use cosine. W is equal to mg. Now let's substitute. T1 is 4, so 4 cosine 30 is equal to T2 cosine alpha. We don't know what it is. 32, yeah, plus mg. The mass is 0.3, and g is, if it's not given, it's 10. Okay, so you're going to get 2 radical 3 is equal to T2 cosine alpha plus 3. Okay, so we now have 2 equations. We're going to call this one here equation 1. We're going to call this one here equation 2. Okay. Obviously, we need to find T2. Okay. Whenever you have T2 sine and T2 cosine, I always prefer to find an expression for T2. Obviously, we need to substitute T2, right? I always prefer to have cosine down because sine over cosine will get you tangent. If I find an expression for T2 here, I'm going to get sine, it's going to be down. And if I have sine down, I plug it in here, cosine over sine, that won't work. I want it to be sine over cosine. Okay, so I'm going to find an expression for T2 using the one with cosine. Always when you have sine and cosine, find an expression using the one with cosine. okay, because it will make your life way easier. طيب, you're gonna get now, find an expression for t2. You're gonna say that t2 cosine alpha is equal to 2 radical 3 minus 3, right? So you're gonna get t2 is equal to 2 radical 3 minus 3 over cosine alpha. This is the expression for t2, right? So here I can substitute t2 with this. So I'm gonna get 2 radical 3 minus 3 over cosine alpha times sine alpha is equal to 2. Okay? Sine over cosine is going to get me. Okay, we're going to do this. Okay? I'm going to put it like this. Arrange your work, guys. So you're going to get this. You're going to get that 2 root 3 minus 3 times tan alpha is equal to 2. Right? Remember, we're multiplying. Okay? How do you solve this? You divide by 2 root 3 minus 3 on both sides. So you're going to get tan alpha is going to be equal to 2 over 2 root 3 minus 3. So you're going to get that alpha is equal to inverse tan of 2 over 2 root 3 minus 3, which is, do it on our calculator, shift tan 2 over 2 root 3 minus 3. Oh, the 2 root, the minus 3 goes down. You get 76.9 degrees. So you're going to get alpha is equal to 76 point. It's an angle. And remember, in the exam instructions, if you're watching this for some reason for A level, in exam instructions, it's 1 decimal place for angles. If you get this in the exam, I'm recording for the SAB system. I personally, I rounded to 2 significant figures. Okay. But if you're watching this for A levels, follow the exam instructions, which is 76.9 degrees. Okay. 76.9 degrees. What else did they ask? They asked for the tension in the string. So you need to find it, right? And we found that an expression for the tension, it's equal to 2 root 3 minus 3 over cosine alpha. So I'm going to put this in my box. Okay, we're going to box it up. And then we're going to find the tension in the string, which we said was T2. It's 2 root 3 minus 3 over cosine alpha, which we said is 76.9. So we're going to do that over here. 2 root 3 minus 3 over cosine 76.9. Oh, I think I need to close the bracket. Yup. Okay. You get 2.0. We're going to round it to 3 significant figures. Why? Because again, in the exam instructions, it says to round it to 3 significant figures. Okay. So we're going to make it 2.05 newtons. Okay. There you go. Let's check the marking scheme just to make sure. We have over here, this was 2A, we're on 2B. Okay, so marking 1 for this, 7.2 minus friction. Okay, so you'd get 1 mark for, where am I? Oh, that was question 2. Oh, yeah, sorry. Yeah, so here you would have gotten 1 mark for this, 1 mark for this, and then what did they say? 1 is equal, yeah, 1 mark for this, and then 1 mark for this. Okay, that's how you'd have gotten your 4 marks. Okay, these were all just solving. It's fine. Okay, here we would have got, whoa, that's a lot. Okay, so you would get 1 mark for this. Sorry, let me draw it in red. You'd get 1 mark for this. We said 1 mark for this, resolving. You would get, what else did they say? Oh, I'm opening Microsoft Store. You would get, where am I? Here. Yeah, 1 mark for the FBD because of the resolving. Okay. You would get 1 mark for the shift tan part here. And then 1 mark for the answer. Or no, that's later. Okay. Then this, what we did to find T. Okay. You'd get 1 mark for this. And then for both answers correct, 1 mark. So that's how you guarantee your 6 marks. Okay. That's for this one. هلا I'm gonna go to yeah, that's it for this one. Thank you so much for watching, and good luck in your exam.